Hello everyone, you're welcome to the third part of the electrolysis series, the question and answers. Okay, so we are going to continue from number 21, and by the way, this remains your tutor, Mr. Life Changer. So it reads, a student electrolyzes silver nitrate AgNO3 solution using silver electrodes. Which of the following observation is correct? Now, I already explained in the last video that anytime you have the electrolyte to be a salt of either silver, copper, or gold, like let's say AgNO3, CuSO4, AuNO3, and the anode, especially the anode, is, if it is AgNO3, the anode is silver, CuSO4, the anode is copper, AuNO3, the anode is gold. Whenever you have a situation like this, they have something in common. All of them are lower than hydrogen in the electrochemical series. What you will observe is that at the cathode, at the anode will dissolve, will reduce in mass. Anode will dissolve, okay, or you can say reduce in mass. Then at cathode accumulates. Cathode will accumulate or increase in mass. Okay, so let's see the options here. Option A, oxygen is released at the anode and silver deposited at the cathode. That's not true. That does not happen in this case. B, the mass of the anode decreases and the mass of the cathode increases by equal amount. That is exactly the answer. B is the answer. The anode will reduce and the cathode will accumulate, will increase. Very important. Okay, so number 22 has to do with Faraday. So it says Faraday's first law of electrolysis states that the mass of a substance deposited or liberated at an electrode is, we have different options here, but the answer is that it is directly proportional to the quantity of the electricity passing through it. So B is the answer to that question. Now this one says, which of the following is the correct expression for Faraday's first law? Now according to Faraday's first law, since mass is proportional to quantity of electricity, which actually means IT, so the mass now is going to be ZIT. That's it. Where Z stands for electrochemical equivalent. So the answer to this question is C. Quite easy. Now the next one says a current of 2 amperes is passed through a solution of copper sulfate for 32 minutes 10 seconds. If the electrochemical equivalent is this, what is the mass of copper deposited? Already we have seen that the mass is M equals ZIT. Now the I current is 2 amperes based on the question, that's the parameter. Now the time is 32 minutes 10 seconds, which we can actually convert. 32 minutes means 32 times 60 and plus 10 seconds. To convert 32 minutes to seconds, we multiply by 60. You get that, right? And that will give us 181920, I guess, plus 10. Okay, and that would be 1930 seconds. Okay, so that means my mass is going to be Z. Electrochemical equivalence is given here to be 3.294 times 10 to the power minus 4 multiplied by the current is 2. Then the time is 1390. So this would be what we have here. And if you multiply this, you see that the answer is going to be 1.27, which makes A the answer, 1.27 grams. Okay, this is quite straightforward, even though this usually comes out, especially in physics. Okay, so number 25 says, how long will it take a current of 5 amperes to deposit 1.08 grams of silver from a silver nitrate solution? And we are given the electrochemical equivalent to be 1.18 times 10 to the power minus 3. So that means that we can still use our formula M equals ZIT, okay, where Z is the electrochemical equivalent, and since we are looking for current, time is going to be M over Zi when you divide both sides by Zi to find time. So your mass is 1.08 over electrochemical equivalent 1.118 times 10 to the power minus 3, then multiply by the current. The current already here is 5 amperes. So if you multiply this using your calculator, we are going to be getting 193 seconds approximately. So B is the answer to that question. Okay, now I want to say this, that there is an aspect of the question that is not here, and it's important that I explain this to you. Now, sometimes the kind of question you get here is not that they would give you electrochemical equivalent, but you should know that mass over molar mass is equal to the quantity of electricity over NF. As a matter of fact, it's a promise. I'm going to be making a video, where you need to use this formula. So I'll be posting that as part 4 of this series. Okay. So then the next one says Faraday's second law of electrolysis states that when the same quantity of electricity is passed through different electrolytes connected in series, the masses of substance deposited is proportional to their chemical equivalent masses. Okay, so C is the answer. But there is another way you can actually define that, and that is that the number of moles of substance deposited is inversely proportional to the number of electrons. Is inversely proportional to the number of electrons. That's that's the most basic way of saying it. Okay. Now the next one says the electrochemical equivalent Z of an element is related to its chemical equivalent E and the Faraday's constant by the expression. The answer to this question is C, but you don't need to really bother yourself with this if you're preparing for any of those exams. Now the next question, number 28, says the same quantity of electricity deposits. Now please notice the same quantity. Once you see the same quantity of electricity flowing through different electrolytes, then what I'm about to do should come to your mind. Okay, so because according to Faraday's second law, you can I said that the number of moles of substance, I'll use that as capital L, is inversely proportional to the number of electrons, which means I can say N1 is equal to N2 for inverse relation, which I can write as M1 times the molar mass, because number of moles is mass over molar mass. N1 is equal to mass over molar mass 2, then here we have N2. Okay, so it says the same quantity of electricity deposits 0.54 grams of aluminium, and this is the atomic mass of aluminium. Of course, the valency of aluminium is 3. Don't expect them to give you that. You are supposed to know that in one cell. What mass of nickel, the molar mass of nickel is this, and the valency of nickel is +2, would be deposited by the same charge in the second cell connected in series. Whenever you see a question like this, you just use this formula. Very easy. So for M1, we take M1 to be mass of aluminium, which is 0.54, divided by the molar mass of aluminium is 27, then times the number of the valency, or the number of electrons involved in aluminium is 3, then equal to the mass of nickel is what we are looking for, so I'll call this M2, divided by the molar mass of nickel is 58.7, then multiplied by the valency, or the number of electrons, is 2. So you can make the mass subject of formula. That means M2 by cross multiplication is going to be 0.54 times 3 times 58.7 divided by 27 times 2. So by the time you multiply this, you should get 1.96 grams. Though I have not confirmed that, I don't have a calculator, so you can calculate that and send me the answer. Okay, then that comes to this one. It says a charge of 9,650 coulombs is passed through separate solution of copper sulfate and silver nitrate connected in series. If 3.175 grams of copper is deposited, and this is the atomic mass valency, 1 mass of silver will be deposited. The same thing. So the same charge flows through both of them. So all you need to do is mass M over molar mass, then N1 is equal to M2 over molar mass 2, then N2. Okay, so that would be the molar mass here. M1 is initial mass for this guy is 3.175 grams. That's M1 represents copper sulfate. Then the molar mass of copper sulfate here is 63.5. Then times the number of electrons, the valency is 2 here. Though don't expect your exams to give you that. You should know that the valency of copper is 2. Then here the molar mass, the mass of silver is what we are looking for. The molar mass of silver is 108, then times the valency of silver is 1. Of course, silver is plus 1. So we can find M2 here. So M2 is going to be, by cross multiplication, 3.175 times 2 times 108 divided by 63.5. Okay, that's quite important. And if we do that, you should get approximately 10.8 grams, which is A. I hope that makes sense. Okay, so we have the last one here, but I already promised I'm going to do some more. Okay, or maybe here. So it says during the electrolysis of dilute H2SO4, 0.1 grams of hydrogen is, and this is the atomic mass, is liberated at the cathode. Using Faraday's second law, what volume of oxygen, and the valency is this, would be liberated at the anode? In this case, now it's still the same thing that we have been doing, but the difference here is that instead of using mass over molar mass, we'll say volume over molar volume times N1 is equal to this other one, volume over molar volume, then times N2. Why? Because whether it is mass over molar mass or volume over molar volume, are you with me? Whether it is mass over molar mass or volume over molar volume, both of them represent number of moles. It's still the same thing. So mass over molar mass is the same thing as volume over molar volume. I want you to note that. So in that case now, that means that V1, the volume of hydrogen based on the question, is, okay, we are not given volume of hydrogen, we are given mass of hydrogen. So let's use mass over molar mass of hydrogen. So the mass of hydrogen is 0.1 grams. The molar mass of hydrogen gas is 2 because H2 is supposed to be 1 times 2. Okay, then times the number of moles of hydrogen. Whenever hydrogen is deposited, okay, the valency of hydrogen is 2. Always note that, because this is the reaction. Anytime hydrogen is deposited, you are going to have this 2H plus giving you 2 electrons to give you H2. So you have 2 electrons here. That's why we have 2 here. Then equal to, in the case of oxygen, we are interested in the volume of oxygen. So we are going to use volume over molar volume. Remember, I used mass over molar mass here because I'm given the mass of hydrogen. I didn't use the volume. Okay, so for oxygen, we are looking for the volume. Molar volume of a gas at STP is 22,400 cm3. Then times the number of moles of oxygen. I know it is written 2 here, but that is not correct. Because whenever oxygen is deposited during electrolysis, this is the equation when oxygen is deposited during electrolysis. You have O2, then 4 electrons. So the number of electrons is 4. please don't forget this in your exams. The number of electrons to use whenever oxygen is being liberated is 4. Kindly note that, please. It is 4 electrons, and this is the equation that validates that. So I'm going to put 4 here. So that means my V2 now is going to be 0.1 times 2 times 22,400 divided by 2 times 4, So I think 2 cancels 2 here. I'm going to be left with 240 divided by 4, and this is going to give us 500. 560, I guess. 560 exactly cm cube. So the answer to this question is B. Okay, so even though I am done with the questions here, but I would like to add this because I thought I added it here, but it's not here. So I will give you an example. So let's say a question like this. What mass of, let's say, silver will be deposited when 2 amperes of current passes through it, okay, for 193 seconds, and the molar mass for silver is of course 108. Now when you're given a question like this, that's very, very simple. Like I said, when you want to know the mass of substance deposited, you can simply say mass over molar mass is equal to Q over NF. Now if you are not given Q, then you will be given current and time, because Q is equal to IT. In this case, I'm going to use mass over molar mass is equal to IT all over NF. Okay, so the mass given in this question is what we are looking for, the same mass. So I'm going to write it as M. Then the molar mass of silver is 108, equal to the current is 2, the time is 193, divided by the number N represent the number of electrons. Silver has a valency of +1, so or an oxidation number of +1, so the number of electrons is just 1. Then multiplied by Faraday's constant is 96500. That's a constant. Faraday has a constant value of 96,500 coulombs per mole. Please don't forget that. So from here now we can now find M. M is going to be, by cross multiplication, is going to be 108 times 2 times 193 divided by 1 times 96500. So you can use your calculator, calculate that, and give me the answer in the comment section. Okay, so you can even let me give another question. Let's say 1930 coulombs of electricity, okay, liberates what volume of oxygen at the anode. Now this looks a bit tricky, but very easy. Okay, all you need to do is, in this case, instead of saying mass over molar mass, we are interested in volume. Mass over molar mass can be replaced with volume over molar volume, equal to Q over NF. Okay, so I should add at STP, and now the volume is what we are looking for. Molar volume of a gas at STP is 22,400 cm cube, or you say 22.4 dm cube, whichever one. So equal to the Q, the quantity of electricity is given to be 1930. You see that? Then divided by N is the number of electrons. For oxygen, remember I said oxygen, you have 4 electrons involved in oxygen, 4. And so this is 4 times Faraday's constant is 96500. So now to find the volume is going to be, to cross multiply, is going to be 22,400 multiplied by 1930 divided by 4 times 96500. So you can use your calculator to get that. and send me your answers. Now, sometimes you may be asked to find time, sometimes you may be asked to find current. All you need to do is to make it the subject of the formula, and you are good to go. Okay, so thank you very, very much. Thank you so much. See you in my next class. Please don't forget to share, like if you are yet to like, share and all of that. I appreciate you all. Thank you.